Hello friends, this is Free Name on YouTube. Today I've been given this, which has been taken out of an office and appears to be fairly rare. So normally when you Google for old BT equipment you get a lot of results and information about the device that you have there in your hands. If you Google for the NTE 2B, there doesn't appear to be a lot about it at all. So I'm making this video in case somebody finds it interesting. I don't know a lot about ISDN or really about this, but I'm going to take as much of this device to bits as possible, and it just might be just a nice bit of nostalgia to anyone who had one of these in their offices and plugged in a phone system to it, or maybe even to some engineers who worked on the network which supported this thing. First, has a really chunky power supply which outputs, in this instance, 9 volts 1 amp, and interestingly plugs into a connector on the underside of this device which can cope with 9 volts or 48 volts. 48 volts is quite often used across some server DC powered equipment, so not surprising that it supports 48 volts as well there. So this thing's on. It's obviously not plugged into the network, so we've got the BT light is lit up red, presumably means that that's missing, and I don't have any ISDN stuff plugged in to any of the customer side ports, which I presume is why the customer light is blinking. So this would probably support up to 30 or 32 channels of calls on ISDN 30, but also possibly 2 megabits worth of data. I've forgotten what the spec is for it. And then the top of the device has this power, the same set of lights that are on the underside. There's also a circuit allocation card here, which appears to be very difficult to pull out of there. Try and do that in just a moment. That does not want to come out. So yeah, this is a Digital Wideband NTE 2B, and probably the thing that makes this quite obscure is instead of it being a copper based service, and I'm going to actually unplug this device now because we don't need it switched on, because I can't do anything with it anyway. So all the customer ports are on the underside here, and we've got a load of stuff I do not understand. So we've got aux channels, alarm interface, presumably if the line drops you can raise an alarm or something, HHT and APS, out in for coax connections for the 4, I guess, potential circuits you could have on this device. So you could have an office with multiple phone systems within it, one on port 1, one on port 2, one on 3 and 4, with 2 different types of connectivity of coax or Cat5 or whatever it would talk over, that RJ45 connector, and then what looks like a much older style connector for the same 4 ports. So yeah, the difference with this and why it's probably so rare is I believe a lot of ISDN 30s were just copper circuits, but if you were far enough away from the exchange or there was something along the route that was interfering with the copper provided service, you could then have this device, if I can get the side off, used, if you can see it with the lighting, I'll see if I can turn that around. There are 2 ST fibre ports. So you would have the equivalent of a leased line fibre that BT would put into your building, and it would use one for send and one for receive. So the data being sent by this unit would go on one of the ports, data being received would come in on the other port. So you'd be using 2 full fibres. So yeah, you'd have a fibre tray in your building, going to a manifold, which probably had multiple fibres running within a tube out of the building all the way back to the nearest telephone exchange. So that's probably why, searching for this specific model, you don't find much about it, because I think BT were quite not keen on using full fibre just to run a circuit like this, unless you were really lucky. Can't get this card out of the back, so I'll just go a bit mad on this with a screwdriver. So it's got a mounting plate which is on the back here, which was screwed to the wall. I'll take that off and we'll have a look at that in a moment. The other thing that's interesting about this is, I guess, also the copper version of this box would be powered, or potentially powered, from the telephone exchange. This one, with optical in, can't retrieve power or receive power from the telephone exchange. So to combat power outages, on this side, the opposite side to where the fibre goes in, it has, and you can see the terminals here, that's the minus terminal, that's the plus terminal, has an inbuilt battery. This one is so old, it has a date on it here, which has faded in the sun and I can't read it there. But yeah, the battery must be probably a decade old, if not older, and doesn't work. But if that was kept maintained, or if this was new, then during a power cut, this device would continue working and providing telephone service to whatever may still be connected to it during a power cut. So let's start taking things to bits. Whoa, that's not what I wanted to do. Whoops. Two screws. Interestingly, the nut has also dropped out from there, which it hasn't done on that side, so weird. Unplug these terminals. And a user 6 volt 3 amp hour battery. When it was being charged, or when I had this turned on, this was putting 12 volts out on these. It seems like quite a high charge current for a 6 volt battery, but I'm also not an expert in batteries. It looks like it's also plastic's deteriorated, or maybe the cells within have expanded, and it's got quite a few cracks on the case there. Anyway, that's the backup battery. You can look a bit further, all the way through actually, to the other side where the fibre module is. Let's see if I can get that circuit details card out of the back of this. So I've undone the screw, I've pulled the NTE upwards, and I was hoping that it would just drop off, but looks like not quite aligned with the holes that it needs to pop out of. So that's back in, that's undone. Haha. Right. We will come back to the NTE in just a moment. This mounting thing has some instructions on it. Yeah, so I guess probably the non-fibre one. I'd have to look this up, so I'm probably wrong about this, but just guessing might be the 1B, and then the 2B might be the fibre one. Not sure. Anyway, instructions on how far apart to screw things to put the bracket on the wall. Coming back to this NTE box, that's the rear side of it. God, this circuit details thing does not want to come out in the traditional way that it would come out. So let's just pull it out there. Oh well, so it even shows here it's not 2 megabits per second, it's 8 megabits per second on the bearer. And we've got a circuit number and some pretty difficult to read writing, probably from an engineer. 850 nanometers, I'm going to assume, is the frequency of light they were sending down, which is standard for non-bidirectional fibre. And it's a shame I can't quite read this. It looks like FGE something, or F and E something, and then CROC, so something CROC, 850 nanometers. Or 850 LOM, maybe, LOM. But there we go, there was one circuit configured on the line sending data to this device. Time to open up the rest of it. Oh, other thing, just before I do get any further into opening this, on the top side, where you've got the easier to see ports rather than on the underside, there is this cover which you can remove, which has EXP, which presumably is some expansion port that would send some data onto some other device as well, but don't know what that would have been used for. It's interesting that it's hidden by default. Once all the screws undone, let's see how easy it is to take the cover off. Cool. So much dust is coming off of this thing. There's the cover, and we have the innards. Complex beast. So inside here, terminals for the battery, presumably power circuitry, which is also on the side. Yeah, see, so power comes in here. You can see the big tracks, goes through a fuse or a smoothing capacitor or something there, and then up to the power circuitry. What's interesting is this front panel is modular. Undo some screws. Feel like I'm missing one or more. Oh no, it's the other way around. This end comes up first. Then we can pull that towards us, and the whole circuit board comes out. Take that faceplate off. We can now get rid of that. So we're down to this bottom, or the actual only circuit board within it. Nothing on the underside of it. And yeah, interestingly, this panel here looks like it should be entirely removable. So you have the board and little jumper pins or linker pins into this incredibly nicely manufactured faceplate with all the connectors on it. So your coax connector isn't coax straight onto the board, it's coax into a daughter board, then onto the board. Whoops. Line that up properly. There we go, back on. And that's basically it. That is this ISDN NTE 2B and the insides of it. Shame I don't really know any more technical details about it, but hopefully this video has been helpful or interesting, I guess, to somebody. If it has, it would be really helpful to me if you wouldn't mind subscribing to my YouTube channel. You don't need to have the notifications switched on, but the subscriber numbers really do help. Thanks very much.